Hi, Olkar here. Today it's time to start the project for real. But before we begin, I just want to mention that I started this project using my custom Unity framework, so some of the code might seem a bit overcomplicated. I had previously prepared the framework with all the necessary functionalities for the game. It's structured into services, all managed by a central controller called the Olkar Manager. This manager allows me to easily plug in individual services and load their functionalities. This modular approach lets me decide which services are connected and serves as a foundation for all future projects. The entire framework also uses something called Bootstrapper, which enables me to load all the required functionalities before the scene starts. This also allows me to launch the game from any scene without losing core functionality, which is extremely helpful for debugging and testing new features.
Nice.
Okay, after that lengthy introduction, let's get to the good stuff. As I mentioned in my first devlog, I want the game to feature smooth character movement. So to start, we need two things: a model and some animations. Let's jump into Unity. First, I'll add a character model. I'll use one I already have in my assets and it fits almost perfectly. Okay, that looks odd. Let's grab an idle animation also from my assets. That's look much better. Now it's time for some movement animations. Since I'm a big fan of Naruto, the character will run like this. But before we start, let's go over a bit of animation theory. Once we are all animation experts, it's time to learn the software that says that it's the easiest way to animate. Let's see that. So now, after we created the next Fortnite dance, it's time to make an actual animation for our game. After what felt like way too long, we ended up with something like this. Well, it is what it is for now. It's good enough. So let's head back to Unity and keep going. Animation presents like this, and as I mentioned earlier, and this was just confirmed, animation isn't my strongest skill. To avoid relying on numerous animations while enhancing the existing ones, we'll leverage physics and math. When the character runs, we'll play the running animation like now, but for turning, we will use a technique inspired by motorcyclists. The character will lean proportionally to how sharply the direction changes during movement. We are going to implement this as follows. We will need the direction that player's avatar is facing, as well as the direction from the controller that we want the character to move towards. Then we'll lean the avatar proportionally to how sharply the movement direction is changing. In other words, the sharper the turn, the greater the tilt angle. At the same time, we'll gradually rotate the avatar towards the intended direction, which will give us a smooth transition as the character leans. Okay, after we implementing what we discussed earlier, here's how the effect looks. In my opinion, considering we are only using a single animation, the result is great. As I mentioned in the concept video, the game is meant to be as responsive as possible, so this approach doesn't take away any responsiveness, because the look direction is independent from the movement direction. That means our character's movement responds only to the direction from the controller. This is possible because the logic has been separated into visual and data parts. Okay, now it's finally time to give our character some speed. Okay, the movement is only partially good, so let's fix that. Let's add some collision, but we won't be using Unity's collision, at least not for movement, because we don't actually want to cause any collisions. And we'll do it like this. We need two vectors, the character's movement direction vector and the normal vector of the object detected by the sensor. If the dot product of these vectors falls within a certain range that we define, we'll create a new vector that runs along the surface of the detected object. This is the player's new movement direction, which replaces the input direction. If the sensors do not detect any collision, or if the dot product does not yield the desired result, we will revert and restore the movement direction set by the controller. This is how we implemented it. We cast sensors at 3 different levels: at the feet, the middle of the body, and the top of the head. The next, I cast rays in a circle around the player, and if a ray hits an object marked as an obstacle, it is added to a collision list. I then use this list to calculate the new movement direction. We recalculate the movement direction data in our model script. After both the input calculation and the sensor-based calculation, we can update our file name movement direction. But before we see it in Unity, I added a new animation for stopping and for quick rotation changes. I'm not completely satisfied with how it looks, but let's skip it for now and let's head back to Unity. Here is how the implementation looks. I think it looks great and the controls feel very responsive. There is one more thing to do with the movement system, and that's adding avoidance for moving object. But first we need to actually have moving objects in the scene. That's all for now. The next video will be about combat, so stay tuned, let me know what you think about the movement system, and we'll see you in the comments. Bye!